Can we truly grasp the mind-bending engineering, the relentless innovation, and the sheer mechanical genius that fuels a Formula One Grand Prix? Because I just spent days immersed in it at the British Grand Prix at Silverstone.
This is Formula One.
Hi friends, welcome back to the channel. If you're new here, I am Destiny, a mechanical engineer entrepreneur, currently a master's student. In this channel, we dive deep into engineering, design, and the history behind machines, innovations, and mobility systems shaping our everyday life. Today, we'll be tackling the pinnacle of mechanical engineering, Formula One racing.
I packed my bags, grabbed my camera, and plugged my head first into the heart of British motorsport, the iconic Silverstone Circuit for the British Grand Prix. Before we dissect the cutting-edge machines of today, let's rewind back, because the roar of an F1 engine today echoes a century of engineering ingenuity and daring. From the very first horseless carriages dunking it out on dusty roads, the human desire for speed and competition has been insatiable. Early pioneers weren't just drivers, they were early engineers constantly tinkering with basic engines and chassis design, pushing the limits with rudimentary but groundbreaking machines. The birth of the Formula One World Championship in 1950 and the relentless march of technological innovation, F1 isn't just a sport. It is a relentless pursuit of engineering perfection. Every year, new material, new aerodynamics philosophy, new hybrid power units. It is a technological arms race on wheels, where every team pours millions into research and development. We have gone from simple leaf springs to active suspension, from naturally aspirated giant to hyper-efficient hybrid power plant, and from the basic bodywork to incredibly complex aerodynamic surfaces that literally sculpt the air. It is pushing engineering to its absolutely breaking point. We are better to experience this ultimate blend of history and hyperspeed than right here. This isn't just any racetrack, this is Silverstone. Originally, it was the Royal Air Force bomber airfield during the World War II. Those very runways you see laid the foundation of what would become the spiritual home of British motorsport. But what is truly fascinating from its engineering perspective is how this track, despite its origin, has been continuously re-engineered to meet the demand of the ever faster F1 cars. Just after the war in 1948, a bunch of motorsport enthusiasts looked at this deserted airfield and thought, yep, this will do. They marked out a circuit with oil drums and hay bales, and the first British Grand Prix was born. In fact, the very first F1 World Championship race in the history was held right here in 1950. Think about the courage and the basic mechanical understanding needed to finish a race on those early configurations. Since then, Silverstone has evolved dramatically. Corners like Cops, Maggot, Beckett, Stowe, and the Club are legendary, but they are also engineering challenges. Track designers have constantly modified the layout for both safety and speed, creating complex sequences that demand incredible aerodynamics efficiency and mechanical grip from the cars. Every curve, every straight, every evolutionary change is a test for the engineers back in the garage. You can feel the layers of history and engineering evolution in every rumble of the tarmac. Now, let's talk about the real stars of the show, the engineering masterpiece that allowed these cars to defy physics. As a mechanical engineer, this is where my jaw drops. Every single component of an F1 car is a testament of cutting-edge design and material science. Modern F1 cars use an incredibly complex hybrid power unit, combining a tiny yet ferocious 1.6-liter turbocharged V6 engine with sophisticated electric motor that cleverly recover and deploy energy. They are not just burning fuel, they are harvesting it from the exhaust and kinetic energy from braking, converting it into electric power. Together, this system produces over 1000 horsepower, making them one of the most powerful and ironically one of the most thermal efficient engines on the planet, reaching over 50% thermal efficiency. It is an engineering marvel of thermodynamics and power management. Aerodynamics is the invisible force that keeps these cars glued to the track. From the intricate design of the front wing to the complex side pods and the curical diffuser at the rear, every single surface of an F1 car is engineered to manipulate airflow. The goal is to generate a maximum downforce, essentially pushing the car into the track, while minimizing drag, which slows it down. This delicate balance allows these cars to stick to the track through the corners like they were literally glued down, enabling insane speed and stability. These machines decelerated from 300 km/h to 50 km/h in under 30 seconds. That's an astonishing feat of engineering. This is due to their incredible carbon brakes. These aren't your typical car brakes. They operate at extreme temperatures, often over 1000 degrees Celsius, literally glowing red hot. It's absolutely critical not just for survival, but for shaving off precious tenths of seconds during overtaking maneuver. Speed isn't just about the raw engine power, it's about the driver's ability to control and exploit that power perfectly. Consider the steering wheel. It's not just a wheel, it's a highly advanced multifunctional computer. Drivers manage everything from the brake bias to engine modes, differential settings, and energy deployment, all from their fingertip. The sophisticated torque mapping and the real-time telemetry from the car back to the pit wall allow engineers to constantly fine-tune performance for changing conditions. It's not just driving a car, it's like piloting a highly sensitive, data-rich missile, requiring an intimate understanding of the complex system. So after breaking down the incredible engineering feats, there is one question that always comes up. How much does the Formula 1 car cost? Let me tell you, as an engineer who understands the R&D, the material and the precision involved, the numbers are absolutely eye-watering. While teams are incredibly secretive about the figures, estimates suggest that a single fully built modern F1 car costs somewhere in the range of $12 million to $20 million US. That's not just materials, it includes the immense research, development, and human capital, the thousands of engineers, designers, and mechanics who bring these machines to life. Okay, you've seen the history, you know the circuit, and we have just peeled back the layers on some of the incredible engineering that makes F1 possible and how much that engineering actually costs. But what is it really like to be here during the Grand Prix? It is not just about racing, although that is obviously the main event. Silverstone transformed into a massive festival of speed, sound, and pure passion. And for an engineer like me, it is a chance for me to see many fascinating applications of design and problem solving. First up, the fan zone. These are epic. From simulators that make you feel like you're actually on track. I tried one, and the force feedback and detailed physics modeling are incredible, to pit stop challenges where you can actually test your speed changing a wheel. These are pure applied mechanics trying to shave off those milliseconds under pressure. And the cars, it's not just F1. There are classic cars display, supercars, concept cars. It's a petrol head paradise. You get up close to machines that are masterpieces of industrial design and mechanical engineering. You can appreciate the lines and composite materials, the sheer complexity. Sometimes, if you are lucky, you will see them fire up those incredible engines, a symphony of precision components. Then there is the atmosphere, the music, the food trucks, the merchandise stores, everyone decked out in their team's color. You meet people from all over the world, united by one common passion. The energy is absolutely electric. For me, it is fascinating to see how the event logistics themselves are a massive engineering challenge, managing hundreds of thousands of people, power grids, communication networks, and waste management. It is a city built overnight and then dismantled.
My name's Ronnie.
Ronnie, nice to meet you. I'm Destiny.
One of the things I also discovered was that helicopter was mainly used in filming the event. This is because modern F1 cars move so fast that drones can't keep up or stay legal at those altitude. So only a chopper can match this piece while giving the broadcaster and analyst a stable area view. Just when I thought Silverstone has shown me every facet of engineering prowess, I discovered something unexpected: the British Army Zone. The Royal Army wasn't just there for a display. They brought an incredible arsenal of tactical engineering, showcasing how the principles of design, durability, and operational efficiency are applied in completely different, high-stakes environment. I am talking armored vehicles built to withstand extreme forces, intricate drone technology, sophisticated missile defense systems, and specialized engineering units designed for rapid development. For a mechanical engineer like me, it was fascinating to see the real-world applications of these machines. I even got hands-on with some of their equipment, learning directly how this tech functions under pressure. It truly highlighted that innovation isn't confined to the track. It is shaping our world in countless ways.
Hey buddy. Cameraman on my spare time as well. There you go. There you go. Look at that. See? One step away from being a racing driver now, ain't you?
Are these missiles or what?
Yes, so these are brimstone missiles.
Okay.
These are air-to-ground weapon. So normally used for like vehicles and that sort of thing.
Yeah.
Then we've got the Ashram over there, that's air-to-air missile. So when you see films like Top Gun, that sort of thing, these are the sort of things that will be using.
Air-to-air missile.
Yes. So against other aircraft.
Wow, so they can explode some.
Yeah.
Wow.
And then we have the paveway bomb over there. So that's the only bomb that we've got in the RF at the moment. So for ground targets.
So they're used for war or something.
Potentially. Again, we try not to use things whenever we can. Really.
Okay. Nice. So what about this? What is this?
These are the 27mm rounds that fit the Mauser cannon over there.
Okay.
On the stand.
Okay, so you place this inside.
Yeah, that'll be inside the aircraft. Wow. And then the rounds, they'll be inside.
After the thunder of the Grand Prix has subsided, I visited the Silverstone Museum. This isn't just a dusty collection of old cars, it's an immersive interactive journey through the history of British motorsport, right here at its spiritual home. Located in what used to be the World War II RAF hangar, the museum is brilliantly designed. They have got everything from the legendary F1 cars that raced right here, even the ones Lewis Hamilton once ride here. You can get up close to the evolution of their chassis design, suspension geometry, and the aerodynamics surfaces. To historic bikes, rally cars, and memorabilia that tells the incredible stories of the drivers and, crucially, the engineers who shape motorsport. But it's the interactive element that really brings it to life for an engineer. You can test your reflexes, yes. You can test your reflexes, yes, but more importantly, you can engage on the exhibits that explain the physics of racing and the aerodynamics of downforce and the mechanical forces that at play during a race. It's designed to appeal to everyone, whether you are a hardcore F1 fan or just curious about the fundamental principles of speed and design. Then there is the ultimate lab, their 360-degree immersive cinema experience. Trust me, you need to see this. You are plugging into the art of the history and evolution of Formula One. My deep dive into the British Grand Prix at Silverstone, it is more than just a race. It is a proven ground of cutting-edge technology, a celebration of human ingenuity, and for me, a mechanical engineer, it is an unparalleled look into how science, design, and relentless innovation come together to create the fastest machine on the planet. From the rich engineering history of car racing and this incredible circuit, to the electrifying atmosphere of the Grand Prix weekend itself, where every component is pushed to its limit, and the fascinating journey through the Silverstone Museum, this place is a masterpiece of motorsport engineering. If you have ever even thought about coming to F1 race, or if you are fascinated about how things work, I urge you to experience it. It is an investment, but it is an investment in understanding the sheer brilliancy of what happens when the best minds in engineering converge on a single goal. Ultimate performance is truly inspiring.